to introduce our guest speaker for this evening. We are honored to have Ms. Marisha Fonseca, a design engineer at Airbus and a proud Sri Lankan who has achieved remarkable success on the global stage. With a strong background in mechanical engineering from Wichita State University and experience in both industry and research, she brings valuable insight into the field of design engineering and space-related applications. Her journey from academic excellence to making a global industry impact is truly inspiring. And today she's here to share that journey with all of us. So without further ado, let's begin this exciting session. Ma'am, the stage is all yours.
Hello, can anyone hear me?
Yes, madam.
Okay, thank you, Rashida, for the great introduction. Good evening, everyone. I'm Marisha Fonseca, as Rashida introduced. I work as a single aisle wing design engineer at Airbus Americas here in Wichita, Kansas, USA. And it's an honor actually to share my journey with you guys. So let me just share my presentation. Can you guys see my screen?
Yes, madam.
Okay. Could I actually, before I start the presentation, what kind of majors are you guys majoring in? Um, like, is everyone in engineering? I heard it's not the case. You can type in the chat actually if you are not comfortable in speaking.
Basically, madam, it's not only engineering. There are people from different fields, but
Okay.
common grounded, like everybody has space enthusiast people here.
Okay, so everyone from the robotic club, right? Like, what are the non-engineers, like engineering majors that you have actually? Is it like business or just to get an idea?
So the engineering degrees which people who are here are from electric and electronic, computer,
Okay,
mechanical. Yeah, ma'am.
okay, cool. All right, sure. I think this is probably. Okay, you guys can see the screen, right? Could you see my presentation slides?
Yes, ma'am.
Okay, cool. All right, so yeah, as I mentioned, I'm from single aisle wing design engineer working at Airbus. So the picture over here is actually the very first picture I took when I came to Wichita State University. So the Airbus office is actually located um, very close to our university. So I was taking a walk and I did not actually know that there's this Airbus facility over there in Wichita. So yeah, that was the very first picture I took in front of Airbus. And then, uh, yeah, within 5 years, I was actually working at the same place. So yeah, it's nice to have that. So a little bit about my journey. Um, I went to St. Paul's Girls' School, Kalania, in Sri Lanka from grade 1 to 5. And after passing the scholarship examination, I went to Holy Cross College, Kampaha. So over there at grade 9, yeah, I did from grade 6 to 9 at Holy Cross. And at grade 9, I had the opportunity to actually go to Singapore to further my studies. So I went to Singapore when I was 14 years old in 2007, and I did my A levels and O levels in Singapore. So after completing them, so I did in math stream in A level. So in Singapore, what we have is just arts and science stream, not like how in Sri Lanka you have like commerce, bio stream, and stuff like that. It's different in Singapore. It's just A level. I mean, science stream or art stream. So I was in science stream. I took physics, chemistry, biology, and also maths as my A-level studies. So I had enough results to go into mechanical engineering degree back in Singapore, but somehow on that year I was not actually selected to for that program. So what was offered was material engineering, and that's pretty much the chemistry side, and I was not like really comfortable with doing chemistry for my degree. So I was looking at other opportunities to do aerospace. One reason was because since 10 years old I actually wanted to be an astronaut. So that's one reason I actually went to Singapore, because I was not actually speaking English back home. And just to get a background of to learn English in a way, like I was too shy to speak English in Sri Lanka. So that's one reason I agreed to go to Singapore, and then yeah, I learn English in that sense. So yeah, somehow so I was kind of looking at the degrees available in Sri Lanka too, and I found Asian Innovation Center that they actually have aerospace engineering degree. So so I came to Sri Lanka to to aerospace engineering, and then I spent the very first year in Ratmalana Asian Innovation Center and did my aerospace engineering. And then from there I got to know that like there's actually American College of Higher Education as well, where you you can actually go to USA instead of going to UK, because the Asian Innovation Center that was there, it's a UK degree program. So since I wanted to be an astronaut in NASA, I was like, there's no point me going to UK. I can actually go to USA. So I changed my from Asian Innovation Center. I jumped to American College of Higher Education, and then I did the very first year in Sri Lanka on that degree, and then I came to USA to Wichita State University to do my bachelor's in mechanical engineering. So the other thing I want to say is like to I heard like in Sri Lanka, to do engineering you had to actually get like three like all straight A's, but it's not the case when it comes to even Singapore. Like my schools were not straight A's. Like straight A's you can actually go to aerospace engineering, but for mechanical they were asking BCC, like so those grades, and then yeah, I had those. So but somehow just in like how Sri Lanka is, like you have to, let's say you got selected civil engineering, and then you cannot change the degrees in between, right, like in the middle. But the same way in Singapore too, you cannot change the degrees. So but in USA system, let's say you decided like, okay, engineering is not my strong suit, even though I started with mechanical engineering, and you can actually halfway through you can actually jump to different programs. Like let's say you want to do business, you can actually change the degree. So there's that flexibility there with the US system, which actually I do admire that system. So uh yeah, so I came to USA, and then I did not do aerospace per se. The reason is like over here, to be going to aerospace sector, it's like very limited, in a sense that you have to have US citizenship to get into like some of the aerospace program, because most of them are like defense related. So like commercial side, it's only, yeah, I'm working at Airbus, obviously I'm not US citizen. So like commercial airlines, you can actually get a I mean with aerospace engineering you can go to that, but it's like very limited job scope. So it was the safest option is to actually do mechanical, and then go to, I mean it will open up to different industry, not just aviation. So that's one of the safest parts. So that's why I did my bachelor's in mechanical engineering. So with that, by the time I graduated from bachelor's, it was COVID. So my professor actually, I mean, people were getting laid off at that point, and then it's let alone like me graduating and then trying to find a job, it's gonna be harder. So then at the same time, my professor actually told me like if I do direct PhD with him, I can actually he can actually fund me fully for the program, for the PhD. So finance was another issue I had at that point. So I was like, yes, sure, I will do direct PhD in mechanical engineering if you can, 100% give me a scholarship. So that's what I did. I started with my professor, direct PhD. And then in 2020, like August, that's when I started the program. But somehow, because of the COVID, he lost his funding. So with that, he was not able to fund me fully for the program. So with that, I kind of was looking for other areas to, find an internship. So that's how I actually found Airbus. So yeah, I was doing my research with my professor, and at the same time, I was working like part time. That's what we call here, like 20 hours. So I was doing 20 hours of part time work with as an intern, alongside with my PhD research. So while doing that, that's how I got introduced to Airbus. So the internship that I did with Airbus was actually not that with Airbus. It's like there's like this company called Quest Global. They are the one that I did the internship with. So what they does is like they are actually like so inside Airbus you're not just having just all Airbus hired people. You have different other companies actually coming over there to work and then support Airbus, something like that. So we call them like supplier. So it's a supplier company, and then pretty much what they was looking for me was to have someone point of contact inside the Wichita office, to be a point of contact pretty much, because this Quest Global was actually based in India. So what they do is so so all the Airbus projects, it's like there's no enough headcount to finish all the projects that they get in a year. So sometimes with that they actually outsource to different companies, and then they have engineers working, and then they are actually doing those some of the projects with us. So that's how I actually got into Airbus, as a, you can say, as a supplier. But I was not paid by Airbus. I was paid by Quest Global, but I was working inside Airbus as an intern. So with that, I kind of fell in love with what I was doing. I was a design engineering intern, and uh, with that, and then so I was focused a little bit more on doing the engineering work over there at Airbus, and then somehow my PhD research kind of got diluted to material side mostly. So it's supposed to be aviation related, and then somehow with the funding and everything, it kind of became like very material based. So I did not really enjoy the PhD at that point, and then obviously I had to like earn my way through just to get the PhD too. So since I actually skipped my master's degree and then straight away from bachelor's I went to PhD program, I had the opportunity to actually step down to master's if I wanted to. So uh I mean, that was like a very debateful time of my life. Like, I don't know, like, because if I continue like another year, I would have gotten the PhD. But I made that decision just because, let's say, I got my PhD and then I specialized in material engineering. And then at that point, my job scope gonna be limited again to material side, because PhD is like a very specialized side. So um, I'm pretty sure I know that I'm not gonna enjoy that too, because the reason I left Singapore was because I did not want to do material engineering, and somehow I was circling back to that. So I kind of made the hard decision, like I'm gonna step down to masters and then graduate with a master's. So I had enough credits at that point to complete my master's degree, and I decided in 2023 that I'll graduate as master's. So the picture in the middle is actually my at my graduation for masters. I wanted to wear a sari just because in Sri Lanka, obviously, when you guys are doing the graduation, you do wear sari, but over here, yeah, it's not sari. I mean, you do wear like a frock or anything you want, pretty much. And for my for my bachelor's, I wear a frock, but just because I know that that's the last degree I'm gonna get, so that's why I decided to wear a sari on that day. So, yep. And picture on my left. It's actually four of the NASA engineers, and that was actually a simulation that I did back in Singapore while I was studying my A levels. It's actually astronaut selection simulation. So pretty much what they were telling us is like how astronauts actually go through the training before they go to space. You know, you have like underwater diving, and then you had to do pretty much like experiments. So we had like that was the very first time me wearing a scuba suit for the first time anyway. And then we had to like go under water like 10 meters deep, not 10 meters, 10 feet deep. Was it 10 meters? Yeah, I can't remember, but somehow about 10 feet deep. And then we were asked to like screw the bolts and nuts together and stuff like because you're wearing this uh, the helmet and it's air, and then you are communicating with the water, so it's like the perception is a little bit different. So that's why they want to make sure that yeah, we can actually screw the bolts together, something like that. So yeah, we were doing that, and then there was like lectures saying what kind of radiation that the astronauts can get exposed to and everything. I enjoyed that program. So because at that point I had the dream just to be an astronaut, and it got changed once I came to USA. I'll talk about it in a later slide, but yeah. So at as of today, I have a 2.5-year-old daughter, and also my husband. He's actually finishing up his PhD in Poland, PhD in astronomy, and right now he's here in for a short while. So, yep, that's pretty much my journey. So I'll talk a little bit about Airbus before I dive into what I do in a day-to-day life at Airbus. So as you all know, Airbus produce aircraft, right? So we have A380, it's not in production anymore. But yeah, it's the double-decker plane. The reason it's not in production is because it's not that full economic compared to other aircrafts we have. So yeah, it's kind of losing money. So we are not gonna produce any A380s anymore. So if you have ever a chance to fly on A380, please do so because it's not gonna be available pretty soon. So yep. Um, and it's a huge aircraft, so yeah, pretty amazing. I only had one time I've flown on an A380, and yeah, it's pretty cool, and it's different. Yeah. So A350 is our wide body aircraft. We call it wide body when you have more than one aisle of aircraft seats. So like 10 across, those are like wide body aircraft. So A350 and A330, those are our wide body aircrafts. And A320 is the single aisle aircraft. So when I say that I'm a single aisle wing design engineer, I actually work on this A320 and on the wing aspect. So the most of the stuff that we work on is actually wing related. So that's why I had to say I'm a single aisle wing design engineer because there are more, wide body aircrafts and those stuff too. So A340 not in production anymore because it's too old. It's got replaced by A350. So ACJs, those are the private jets, and not only just commercial side, we also have military aircrafts as well. Not so much familiar with the military side, but yeah, we do those too. And obviously not just aircrafts, but we do actually helicopters as well. And H160, I think is the latest. Yeah. So apart from those, we actually are super involved in ESA with European Space Aviation as well. So they launch satellites, and also they do like some air-to-air refueling operations as well for military-based customers. And yeah, some cool satellites. Yeah. And if you read this, so we develop technologies that allow humankind to explore space and build the module that will propel the first woman to the moon. So when you say first women to the moon, you know about Artemis 2 already. So yeah, we are pretty much really involved with that Artemis 2 mission as well. I will tell more about it in later. But yeah. So so air transportation, they all have like a goal to be 0% carbon emission by 2050. So Airbus is actually working on those goals too. I'm not directly involved in those projects. Most projects are actually done in Europe just because they are our mother. I mean, the USA, Wichita, this Airbus location was actually just was like I would say. Yeah, it's about 20 years ago that they actually had this location, but obviously Airbus been there for more than that. So it's a Europe company. They just started doing USA productions and those things as well. So yeah, at least our facility, we don't do any R&D stuff. Mostly those are in Europe, in especially France and Germany. So they are the one actually working on this sustainable aviation fuels, which is like a aviation fuel that they are trying to put into our existing aircrafts that are from renewable energy sources. So yeah, and then they are trying to hit about 30% of those, like 30% of SAF by 2030, and it goes to 60% by 2035, and by 2050 they are looking at hydrogen fuel cells to make it 100% carbon free fuel. So yep, that's something we are working on as well. So yeah, so as you all know, like product phases of product engineering life cycle is pretty much similar across all industry, I would say. So for Airbus, if I say it's actually you have the idea to build a plane, let's say a new plane design, like okay, A321XLR, that's our very new plane. And then you pretty much gather data and everything, and then go through you design it, like do CAD design and stuff like that, and then you go through like certifications and everything, and finally you will release the aircraft, for example A321XLR. And then so most of what I do is actually maintenance and support, because the A320 aircraft is actually already produced, and then it's been in operation about 30 years. So what the projects we do at Airbus is mostly like maintenance related. So let's say Emirates come and say like, okay, I noticed that this rib have like corrosion coming up, and then can you actually look into it? So it goes to engineering facility, and they will um, analyze it, say that can we actually replace with another material, like composites and those stuff. So we'll look into those, and then pretty much do the research and everything, and then okay, yeah, this is a known problem, and then we this way we could actually fix it. So then we go to our drawings, like the existing engineering drawings, and then we fix it. And then it will go through like a release process. Like let's say somebody designed the drawing to be that, and then there will be like a checker actually like check our work, saying that like okay, it's up to the Airbus standards and it's good to release. And then it will go to a stress engineer, and then they will look at it saying that okay, yeah, the loads and everything do matches, and then yeah, it could be, I mean, those can be released, and then he sign off, and then it will go to like different, like even for manufacturing engineer, they will look at it saying that okay, this can be manufacturable, and then he will sign it off, and then finally it will come to the design office again, saying that like a design engineer, like a very, I mean, I don't have those authority. You have to have at least like 6 years of experience working at Airbus just to get a certification. That's how, like, I mean, how Airbus puts like so much emphasis on safety, make sure that people who signing off actually knows what they're doing. So, and then they finally sign it off saying that okay, this drawing is ready for production. That's where we release the drawing. So that's pretty much the like how what we do at our Airbus. So like I said, like, so I work at it. I mean, this is one of the aircraft that I work on. So, but different sections are actually produced by different countries. So we have a fuselage that's produced in Germany, and then you have the front cockpit. They are actually produced in France, and then the horizontal stabilizers, they are actually produced in Spain, and then finally all these parts will go to a final assembly line, and then where they actually get assembled together. So the projects that we get is mostly from UK, and they are actually specializing in wing. They produce the wing, and that's why I say like I'm a wing design engineer, because the most of the stuff we are working on is the wing. So yep. So this is actually the structure of the wing. So you have I mean, with the skin outside, you don't see inside. This is pretty much inside the skin. So you have ribs, and then you have stringers going across, and then also the flaps, ailerons, and also front spar. Yeah, there's spars going across too. So this, and then all these are pretty much broken down into really small parts. Like even though you see the whole rib is like the red, and then it's actually you have like front rib and then mid rib kind of thing. So it's actually different part, even yeah, that comes together. So I don't know how many parts we have. So when you look at it in CATIA, it's actually uh small parts that you actually focused on and then work on. So this is not Airbus. I found this online because I'm not actually able to release any of our drawings per se. So yeah, this is pretty much the lighter green and lighter yellow color is actually the skin, and then you have the ribs, and then stringers going across. So yeah, this is the spars. Um, so this is actually the CATIA software that we in Airbus we use. So for computerized aid design, you can actually have like SolidWorks, AutoCAD, uh, and 3D Experience or CATIA V5. So and Airbus, we still uses CATIA V5. So that's our software, and then that is what we use to do our 2D drafting, like engineer drawings, and also to build our models. So um yeah, so this is actually in production. Like what you can see inside a wing, like yeah, this how the actual parts kind of look like. So these are stringers going across. So yep, that's just a picture. So this is one of our engineering drawings, what we do. So if I explain like these are some of the notes. So these notes will say like, okay, drill this part, bolt this part, and then like, okay, apply a protective treatment, and those kind of notes we will say in a drawing. And then uh yeah, pretty much what a manufacturer engineer need to know, we will say state in a drawing. And then yeah, so we use CATIA V5 software to actually draft this drawing as well. So some of the stuff that we do, and A320 especially, is because like I said earlier, the plane is actually produced like 30 years ago. So so all these earlier engineering drawings are not computer based. They are actually handwritten engineering drawings. I don't know like if you have actually practiced the handwritten drawing, but back when I did my aerospace engineer at Aviation Center Ratmalana, we were actually asked to like get a like a handwritten drawing. We were doing those things, and it was pretty much fun. I mean, when I came here, everything is computerized. I don't know if you guys still use that back home. So yeah, it was pretty cool to do everything, using all those utent tools, and then like drawing it by hand. That's pretty cool. Like I enjoyed doing that. So yeah, in here university, I did not do a single of that stuff. We were only doing the computer ones, like the 2D drafting. But yeah, so like I said so earlier, all these are handwritten drawings, and then so we have to actually, because and then it's pretty much outdated, and then everything is now computer based, right? So we have to actually take those handwritten drawings and then produce in make a model in CATIA, and then also do the engineering drawing. So that's now one type of project that I was working on. Yeah. So yeah, so like I said earlier, we are actually involved with Artemis 2 as well. So and yeah, these are the 4 astronauts right now on space, and then they are coming to Earth orbit in about 8 hours, I guess. So yeah, and then so this is the oh my god, sorry. Okay, oops. Okay. So this is the European Service Module that Airbus actually built on behalf of ESA. So yeah, it's actually the powerhouse for the Artemis 2 crew mission. And then this crew model is built by Lockheed Martin. So it's pretty much went all the way to flyby and then coming back. I think, if I'm not wrong, we are in somewhere here right now. And then about 8 hours, I think it will gonna get burned out in space, the European space module, when astronauts getting re-entered to the Earth. So I have a video actually. I'll just share the video. Let me know if you cannot hear the sound. So
a new era of space exploration is unfolding. Artemis 2, the first crewed mission to venture around the moon in over 50 years. 4 astronauts, 10 historic days. Powered by the European Service Module, designed and built by Airbus for ESA, the heart of the Orion spacecraft. Once beyond Earth orbit, the European Service Module takes over, maneuvering the spacecraft, powering every system on board, charging the batteries, enabling the crew to work, sustaining life in space, providing air and drinking water, keeping Orion at the right temperature, propelling the spacecraft to the moon and back. A journey of 1 million kilometers to test every system. Astronauts taking the helm, manually piloting the spaceship, checking thrusters for maneuvers, preparing for future docking. The European Service Module leads the way, guiding the crew through deep space, a lunar flyby, revealing views no human has seen before, bringing the crew back towards Earth. Mission complete for the European Service Module, proving its ability to support life in orbit, paving the way to land on the moon. Europe at the heart of the Artemis missions.
yep, that is what we did for Artemis 2. Oops, sorry. Okay, little bit of breakdown on to European Service Module. So you have the consumables tanks provide the astronauts with air and water for a 3-week mission. They're only up in space for 10 days, but okay, there's extra water and air. And so there's these 33 engines provide thrust and propulsion to maneuver Orion to its destination. There's 1 main engine, 8 auxiliary thrusters, 24 smaller thrusters, and 8.6 tons of fuel. So, and you have solar arrays, 4 of them, and with their 15,000 solar cells, convert light into electricity to power the spacecraft. They provide enough electricity for 2 4-person households on Earth. The avionics automatically, where is avionics? Okay, this part. The avionics automatically regulates solar array rotation, propulsion, water, breathable air, power, and temperature. 12 kilometers of cables relay this vital data. There's a thermal control system maintains the crew module at standard room temperature despite the extreme heat and cold in space. So the space is, I think, minus 200 degrees to plus 100 degrees Celsius. So yeah, that's what we did actually for Artemis 2 mission. And it's not just Artemis 2. I think they already built stuff for Artemis 3 and also Artemis 4 as well. So all the way to touchdown on the moon, Airbus is involved. So yeah, we are helping space exploration as well. So do I need to tell anything about it? Okay. So this is actually the case study that I got to know after I came to USA that actually changed my dream of becoming an astronaut. Funny thing was, I was actually planning to be the first woman astronaut from Sri Lanka. So, but yeah, I gave up that dream after learning about what happened on the Space Shuttle Challenger disaster. All I knew before I come into USA was that Challenger disaster happened because of an O-ring failure. I mean, I did not know it was a known problem, that NASA had it even before the shuttle launch. So that kind of made me realize that I don't want to be a guinea pig. I mean, you are sitting on a rocket thinking that it's a proven system by all the engineers, and then but they did not tell you that, okay, there's a known problem and you might actually die. Just it became politics in that sense. So um, I don't know how many of you have actually known what went wrong and everything, but I will tell you since you guys are Rocketry Club. So this is Challenger orbiter. And so you have for space shuttles, you did had right solid rocket booster and then also left solid rocket booster, and you also have an external tank. And yeah, this is pretty much the setup. And so what happened was on that day, so this space shuttle Challenger actually got it was supposed to launch on another day, but then it actually got delayed quite I think it's about 6 to 7 times. The launch date actually moved backwards. So obviously NASA was getting sponsored by all the militaries and all those they had all those sponsors, right? So those sponsors were like, why are you like delaying the shuttle launch? So that's like immense pressure for management to actually put this Challenger in space. And then because obviously delaying is also like money involved, so that's one thing. And somehow on the date of the Challenger launch, the temperature was actually about 1 degree Celsius or 0 degree Celsius. I mean, it's freezing cold. Even though it is in Florida, it was freezing cold. So the engineers knew from the previous shuttle missions that when the temperature is actually lower, the O-rings are not functioning well. So O-rings are actually the ones that up here because your solid rocket booster is not one whole cylinder. It actually have broken down to different small cylinders. So these O-rings are the one actually keeping those two cylinders together. So it's pretty much like a glue, acting as a glue, and then putting pressure on holding the two cylinders together, two rocket booster cylinders together. So when it's actually cold, what happens is, since it's like a rubber kind of material, it won't expand properly. It will like be in a compressed state, and then when the hot air passes through them, it cannot actually expand well as it's supposed to, because it's too cold for it to. I mean, same thing, like if you have a rubber band and if you stretch the rubber band, it will stretch and then it won't hold its place. It will still come back if you let go. So it's the same thing with the O-ring too. But if you put the rubber band in a freezer and then make it freezing cold, if you try to stretch it, it will break, right? So it won't go back to its shape. So it's the same thing. It was too cold on that day to be launched, and then engineers knew the rubber will not perform, and then it will break, because for the rubber band to function again, you actually have to have warm temperature first, and then so that it can come to its operable temperature, and then you can stretch, and then at that point it won't break. So the same thing, but engineers were not able to explain properly to management. So they knew this risk. There's a risk of the space shuttle gonna go blow up, but it was like a poorly presented to the management why it is a catastrophic disaster, and so the management knew there was an o-ring failure, but they thought that the risk is acceptable, so that is how they sign it off, in that sense, saying that this o-ring failure is acceptable. So like I mentioned, so from previous rocket shuttle launches, right? So when they actually come back, they actually noticed that, so I think it was on the same year. So there were like 7 shuttle launches prior to Challenger. And then they noticed that out of those 7, 5 of them actually have O-ring failure. So they actually have 2 O-rings. And then the second O-ring is actually the one just to act as a fail-safe, just if the first one fails. So what they noticed is that even at 53 degrees Fahrenheit, that is actually about 11 degrees Celsius. So at that point, the O-ring, the first O-ring have failed. And then it was because of the second O-ring that it did not blow up at the relaunch. So yeah, so engineers knew like with the lower temperature, the O-ring's not gonna perform. So they were saying a temperature of like at least on the day of the launch, the temperature had to be at least 11 degrees Celsius or higher. But that day, it was actually at 0 degrees Celsius, and there was like ice everywhere. And then they actually de-iced before the launch, and then it kind of a little bit delayed on that day too. But somehow, they cleared the launch. I mean, some of the engineers who actually built those rocket boosters said that I cannot sign it off. I mean, it's gonna blow up at the launch pad itself. So, and then somehow he actually passed that down to someone, and then I don't know if it is a bribe or something. Somehow NASA got clearance from the engineers saying that it's acceptable risk, but you still can launch. So that's how it happened. So the engineers who actually did not sign was actually expecting it to be blow up before even launch. So because if the O-rings are not gonna hold it, the hot air gonna come out, right? And then it's gonna blow up at the launch pad. So that's what they thought. So, but somehow Challenger managed to lift off, and then at 73 seconds, it actually blew off. So it got exploded. And then the other sad part is like you're sitting on the crew module, and then that crew module, they have the videos, like the crew module actually was separated from the whole launcher, but then they only died at the point of hitting the ocean. So that's sad. I mean, they survived the explosion, but still somehow they died. So me knowing that, and then it's like a knowing problem. I never wanted to be a guinea pig. Never wanted to work at NASA, and I never looked back after that. So it's just on Artemis 2 that I was like a little bit curious about the space exploration again, but yeah, I kind of gave up on that dream, just realizing that. So I think it's much better now with the system and everything, but I think Airbus is better than NASA in all aspects in that sense. So, okay, so Challenger Space Shuttle. Okay, this is a picture of the Apollo 1. I think you guys know that it actually, during a test flight, testing that they were doing in the crew module, because of an electric fault, it actually, these astronauts were inside the crew module, and then because of an electric fault, it ignites the oxygen environment, and they died. And then this is actually the Challenger crew. There were 7 astronauts, and one of them were actually a teacher that was saying supposed to go on that mission, and then actually like do lessons from space to students. So yeah, it's a strategy. And then this is the other space shuttle disaster, which is the Columbia, that actually blew up during the reentry. So yeah, so the Challenger space shuttle failed because of an O-ring failure, and then the shuttle design itself is actually very complex, and also it's not the ideal design that the NASA initially wanted to have, but it was actually the one that is economically, financially feasible to and doable. So that's why even the solid rocket booster, they could actually make it one huge cylinder, but then they decided to break it down to like different cylinders, just because it's cheaper in that sense. Like even at the transportation, it's much easier to transport. I mean, those solid rockets rocket boosters were actually built in Utah, which is like a different state, and then it had to be come down on the railway all the way to Florida at Kennedy Space Center. So it's a long journey. I mean, to have it as one whole big booster, one cylinder, it's actually gonna cost money. I mean, rather than having it small parts. So that's why the O-ring even came. It's actually a affordable solution. So, and then NASA culture is pretty much like they actually focused on politics in a sense, like rather than not listening to engineers. And then at the same time, yeah, all the money was pretty much involved. I mean, NASA get funded from US military and all these other stuff too, because they want to put their satellites onto space. So that's how the shuttle mission was kind of funded too. So when you have immense pressure from the sponsor to actually fund the mission, then yeah. But one thing on this disaster that engineers failed to bring up to the management was because of poor presentation. They did not know how to say in a way, because the way that they actually showed sorry, I did not include that presentation actually, like what they showed actually to the engineers, to the management actually. It was pretty much numbers. They just gave like at 53 degrees Fahrenheit, it's actually only the optimal temperature that, I mean, it's the lowest temperature that we are going to allow, at 11 degrees Celsius. And then below that, we are saying it's a no-go, for the shuttle. But they did not say like in terms of like why it is like that. They did not take like the, like how I tell you about the rubber band example, like, yeah. So they were telling about engineers' way and then putting the numbers out to the management, and then management did not get it. So in that sense, they were like, okay, it's an acceptable risk. It happened before, but it's not something catastrophic. That's how they took it as. So yeah. So lessons learned is like engineering ethics, in the sense that you actually have to make sure that it's safe because human lives are actually at risk at that point. So, and then also engineers need to know like how to make it presentable to non-engineers. I have a video actually that I can show you how the judge actually explained it. Hold on. Yeah, this is how the judge actually presented
the event. The information that was available and understanding it was available. Was it fully appreciated everywhere that this seal would become unsatisfactory at some temperature? And was there some sort of a suggestion of a temperature at which the SRB, I guess you call it,
Yes, sir.
shouldn't be run?
Yes, sir. There was a suggestion of that. To answer the first question, given the configuration that we ran, that the seal would function at that temperature. That was the final judgment.
But Commission Member Richard Feynman, after examining the O-ring, had a surprise.
Well, I took the stuff that I got out of your seal and I put it in ice water. And I discovered that when you put some pressure on it for a while and then undo it, it doesn't stretch back, it stays the same dimension. In other words, for a few seconds at least, and more seconds than that, there's no resilience in this particular material when it's at a temperature of 32 degrees. I believe that has some significance for our problem.
So yeah, at that point, NASA actually, the rubber actually lost its properties, its material properties, and then that was a physicist who actually explained that. So, yeah, who was on the judge panel. So, yeah, that was a sad truth. And so this is just a summary of like what kind of qualities like an aerospace engineer should possess. So, at least for Airbus, you cannot do anything engineering related like design engineer or stress engineer or manufacturing engineer if you don't have a basic engineering degree, sadly. So pretty much engineering degree is like the foundation for you to actually like go to do engineering. And then CAD is like computer design. Like I said earlier, you have CATIA V5 3D experience or anything computer aided design softwares would be fine. And also a huge is important is actually have to be you have to be a team player, because when you actually coming together even to like solve a problem, it's actually like a team effort. You have your senior engineers and then everyone coming together and then trying to find a good solution, I know I heard from some other industries like sometimes you would have like immense pressure to just release a drawing, like get it done, something like that. But at least, I mean, we do feel pressure in our workforce, like, but it's not always, but if let's say if there's a safety concern and then they cannot sign it, they won't sign it, in that sense. So which I really do admire at Airbus. Even though we feel pressure, if we can explain what's going on, why is there a delay, and then let's say if we say that okay, we need to find out if this is if let's say the stress at that location, I'm actually not sure, I need further information from a structural engineer or something like that, and then as long as we can explain it to the management, they're okay, so we have like our engineers and also like project managers, and they're the one actually deal with the budget and everything, how much a project could have, what kind of budget, and then with that they divided into how many hours we should how many engineers and how many hours they should spend on like finishing up this project, something like that. So let's say when they feel like okay, they are not finished yet, and then they are still like working on it, and they are actually going over the budget. At that point there's sometimes us like what did you do, like why it's not really. So if we can explain, and it's not like we waste our time doing nothing, so and at that point they are like okay, let's get more money, to finish the project. So it's always like that. It's not like okay, because the money is over, just get it done, just released it. So it's always not like that, which I do admire the culture of Airbus in that sense. So obviously you had to be these are some of the soft skills I just listed. You had to have your integrity to do the right thing when no one is looking, and also to be reliable as possible. uh, Make sure that what you do is actually right, and then people can rely on it. And adaptability also, for example, now we have like AI coming into Airbus too. We have like Gemini and Airbus AI. It's like we use that to help our day-to-day life, even to like draft an email or something, we use AI. I mean, it's already inbuilt to the uh, Airbus Gmail part as well. So that's nice. I mean, all these things you have to like keep like current with everything, and then be adaptable to changes as well. Some I have like some senior engineers working with me, and then when I say like okay, you can actually ask Gemini about this stuff, and he was like no, I'm not gonna do that, and he have not even turned on those things. But yeah, but they are seniors about retired, so but if we want to survive, we kind of have to make sure we are up to date with everything. And obviously, as an engineer, you have to have problem solving skills, and also attention to detail. And like I mentioned, with the challenging disaster, ethical thinking, and also be creative to look at the broader picture. So let's say if you're just working on a rib section and everything, but you fix the rib, and then if it is affecting somewhere else, you have to make sure that you are open to that, and then see how your changes affect around you. So yeah, I have two more videos that I will share before I'll answer open up to Q&A. Uh, those are from Airbus actually. Okay. Yeah, that's a video about A320 actually. That's actually the highest selling aircraft at Airbus, so glad I'm got to work on it. So, uh, hold on, I have another one that they actually put up to recruitment. How do I move this? Okay, there you go. Okay, that's pretty much the end of my presentation, and you guys can ask any questions actually that you have. I mean, feel free to ask in Sinhala if you're not comfortable in speaking. In English, that's fine too. I mean, I know I was once, so yeah, just let me know your questions. Feel free to ask anything actually. I mean, if you want to know anything outside of what I covered, that's fine too. Yeah.
So,
I'm
as a
pretty much open
mechanical
to it.
engineering undergraduate, what are the future opportunities we have in either in commercial or defense aerospace engineering projects?
You asking especially for aerospace sector or for everything?
Yeah, aerospace.
Aerospace. So if I tell about USA, it's pretty much limited to commercial. Unless you are a US citizen. I mean, if you are a US citizen, obviously you have like what you can go to Lockheed Martin, and also SpaceX there is there, and yeah, we have Airbus, and then also Airbus helicopters as well. So I mean, yeah, all this you can go and. Oh yeah, we have Boeing too. So yeah, I mean Boeing and Airbus or Airbus helicopters. If In Airbus helicopters, I think USA mostly focusing on defense. So no, not true. You still can go. I mean, I have a friend who is working in Airbus helicopter, and she's not a US citizen. So yeah, you can go all these places, and then um, yeah, there are actually a lot of opportunities too. So outside of USA. Um, so obviously Airbus is a Europe company. I mean, it's actually in 180 different countries too. And then also you have European Space Agency. I think for that, you don't have to have citizen to be a European citizen to go there. So those opportunities are there too. Um, yeah, in Airbus sectors, there's a lot. So yeah.
Hello, am I audible?
Sorry?
Am I audible?
Yeah, I can hear you actually.
So, as in for we are still undergraduates, are
Mhm.
there now in Sri Lanka we don't have much of this sector to join any much of projects going on. So, do you have any recommendations, anything like kind of programs or anything that is happening abroad that we can join to learn something new?
To learn something new. Are you talking about especially like engineering sector or just space sector?
space sector, and it would be nice if you recommend some for the other sectors too.
Okay. So there's this European Space Agency, not European Space Agency, Space Generation Advisory Council. Have you heard about it?
No, not personally.
Okay. So I actually went to Poland in 2017. It was like a mass analog simulation. Let me find if I can just share my screen and then search in online. Hold on, space generation. So yeah, there's this Space Generation Advisory Council. That's something I actually like. They have a lot of conferences and stuff like that that you can participate on. Let me share their website. It's still going on in Sri Lanka, right? Okay, yeah. I mean, my husband is pretty much like super involved with those things. So let me find a website that I can share with you guys. So that's something too. And then obviously, are you thinking of like after studying like in Sri Lanka, are you thinking of like going to like do masters in outside of Sri Lanka?
Still no plan about that.
Okay. Action like Monsoon. Hold on, my husband, since he's actually like, doing all those, he's pretty much familiar in like Europe side. Let me see if you can you talk? Why not? He's too shy to talk. Wait, I cannot even find this. Okay, let me write down on the group chat. So you have Space Generation Advisory Council. So in that, what I did was like they had different groups. If you go to the website, why I cannot go to the website? And I actually like joined with them to do a mass simulation. And I know my husband, he actually went to like Thailand and Indonesia just to have like some conferences too. Why I cannot find the website? Next to them. What's happening? Why it is not? There you go. Okay. So that is one that you can register as well. And let me get, yeah, I found the homepage. This is another place that actually you can get internships. International Space University in France. Oh, was I directing only to one of Vinny? Were you the one asking question? Sorry, I was sending to one person. I'm sorry. Give me a second. I was only sending to one person. Did you got those links actually? Hello?
Yes, ma'am. It's in the public chat.
Okay, good.
Thanks.
Somehow there was only one person. Okay. So I sent 3 links. Yeah, there are some like internships that you can do, and then Space Generation Council, you can actually register with them, and then there's like conferences and stuff that you can attend, and then yeah. Okay, there should be 1, 2, 3, 4, 5 links. Okay, one of them is actually from Airbus, so hope that helps. And then outside of Airbus, outside of aviation, I actually have to look into those. So if you can email me with your questions and everything, I'll try to find them. I'll give you my email address up here. Okay, that's my email. If you have any questions, then you can actually reach out to me too, and that way obviously I can find more resources for you guys. So any other questions actually?
Am I audible, ma'am? Am I audible?
Sorry?
Am I audible, ma'am?
Yeah, I can hear you.
Okay, so madam, I'm following electrical and electronic engineering. So I just want to know, in like aerospace engineering companies, would they like to hire like engineers for electrical side or electronic side, like embedded systems or like those things, or the power or that kind of thing?
I think they will do hire both. I think as long as you have like an engineering background, it's pretty much like, yeah, you can actually get a job in Airbus. Okay, I have actually one friend, he works at Airbus helicopters in Texas, and he's an electrical engineer, and he actually yeah, pretty much he's the only electrical engineer who's like certified and everything, and he actually only have an electrical engineering degree with a math minor. So yeah, I'm pretty sure that the other side you say electronic, right?
Like embedded
Yeah,
system.
I think yeah. What he actually does is he's actually configuring, like, when customers like for helicopters, it's you have private customers and obviously like military customers and everything, and then when they actually need to have specific configuration, like specific requirements for so he actually do those custom built one, like not really familiar with the electrical, but like he designed the whole circuit system or something, how the wiring and everything. So yeah. um yeah,
Thank you,
I
madam.
think you'll be fine in both. Yeah. Okay, I'm sorry if you talk.
Hello, ma'am.
Yes, hi.
Am I audible?
Yes, are you Omini? Sorry, I think I missed you. Sorry if we talk about this.
No, it's not me. I sent you the message,
Okay.
and I
I'm
wanted to
Pulsara.
know. Yeah, go ahead.
Okay, sorry for the disturbance. Ma'am, can you suggest some thoughts? How can we join with global aviation? We are completing the BSc engineering in Sri Lanka as first degree.
Say one more time. Sorry, I did not get you.
Uh, can you suggest some parts to join with global aviation? We are
Okay.
completing BSc engineering in chemical or civil law, something like that,
Yeah,
as first degree.
correct. Okay. Yeah, so I have a lot of like friends over here that actually they did their engineering degree in Sri Lanka and then came here to do their PhD. I think yeah, I have some who did for masters too, and somehow they were most of them actually were able to get into a PhD program straight away from Sri Lanka. And they after that they come here and then they just go through the PhD program and then yeah. So yeah, obviously, yeah, I mean most of them are actually not most, a lot of them are actually coming after they completed their BSc in Sri Lanka. Yeah,
Ma'am, we just completed our orientation program. What is the
okay.
best field as a thing to join with aviation? Mechanical or civil law, electrical and electronic or computer? What is the best
So
class?
I think mechanical or civil would be better actually, because no, if I'm thinking of my Airbus office, right? So we have a lot of mechanical and aerospace engineers. So pretty much most of like if you go to like design engineering, right? We have more mechanical engineers than aerospace. So so most of the aerospace engineer degrees, they actually go to like stress engineers, and then not like you cannot be a stress engineer at mechanical. I think mechanical will open you up like to a lot, because it's not just aviation industry. Then you can actually go to automobile industry too, or like even oil factory, like a petroleum side and those things too. And then yeah, even like roads, like civil infrastructure, I think even they hire mechanical too. So yeah, if you are not clear on what you want to do, I think mechanical would be best, because yeah, it pretty much cover like a whole scope of um everything, you know like even like they cover like fluids in with considering like air, or even like the like submarines, those yeah, that too. So it's pretty much everything. What I learned is like it pretty much touches every single side. And then so like aerospace, it goes to very deep dive into aviation. Like our degree over here in aerospace, they actually do like they build the whole airplane for for their senior project. But mechanical is like you just learn, okay, these are the four forces acting on aircraft or those things, and then you learn that, and then you jump to fluid mechanics, and then doing those like how like under pressure, like how like submarines will survive and those things. So it's like everywhere. And then you have a bit of touch in electrical engineering as well. It's like some of the courses. So yeah, I think in that sense mechanical would be better if you are not sure which direction you want to go.
Thank you so much, ma'am. It means a lot to me.
Okay. Okay, hi Marisha. I'm sending this message because I think you missed it. I'm sorry if you talk about this at the start of the meeting, but can I know how you got into Airbus at the specific projects you worked on? Could you also touch a bit on the selection process? Okay. So Ovini's question is how I got into Airbus and the specific projects I worked on, and yeah, and the selection process. So mine is actually so I was looking for an internship because I did not have full funding in my PhD program. So so the particular internship that I got is actually I did apply online, but not to Airbus. Like, so we have some platforms like to apply for different industries, and then sometimes we have like career fair that comes to our university, and then kind of like different industries will come, and then they do like a orientation, like a career fair pretty much. And then so we at that time then we can actually submit our CVs to them and then talk with them, and then like what kind of project that actually we worked on in school we can explain. Then obviously if you have like outside projects, it's actually really helpful. That's like the normal way, like you can actually like have like a career fair, or you can actually apply directly at their website. But mostly for engineering, like internships and stuff, it's good to have like when they come, then it's good to have like an internship. So you just submit your CV over there, and then hopefully they will call you, or you can actually like if you whoever that you talk to at that career fair, if you actually can get that get their email address or something, and then have like a follow-up, that would be great too, because most of the like I think that they get hired is if you have a connection. It's actually very good. I mean, you would be hired. Like how I got my internship at Airbus was one of my friend who was actually studying mechanical engineering with me, and he actually had an internship before me at Airbus, and he after that like on during COVID he actually got laid off too, and then he went to a different engineering company, but somehow he have friends over there, and then they actually like contacted my friend asking like, do you know anyone like looking for an internship kind of thing. And then since he know me, he actually asked me, do you want to work at Airbus? So, and I said that's the same time I was actually looking for jobs too, like an internship. And then I said yeah, and then I submit my resume, and then it's like, since it's through a contact, right, like it's a referral. So I think that's how I actually went into Airbus. So I think I mentioned earlier, like it's so that reference is actually from Quest Global. Like it's not directly at Airbus, so it's a supplier company who are actually working in Airbus. Yeah, but so I mean, then obviously Airbus people see how I work and then what I do. I mean, pretty much I did not do much at that internship. So mostly my job was to actually keep good communication going on between Airbus people and then people back in India, like the Quest Global people. So I was major pretty much doing the like point of contact, and at the same time I was actually like helping to do the 2D drawing, drafting, and those things. And then um yeah, even though like let's say it's the communication that I did, but I did it really good. I think they were like Airbus people were impressed by it. And then so when I asked them directly after I was saying that okay, I'm graduating this 2023 May, can I join with you full time, something like that. And then I did not go through like an interview process at that point. They actually hire me. And then so this is after COVID. And then with COVID, right, you have a lot of layoff and layoff happens. So after COVID, then all the projects were like kind of shut down at that COVID time, and then got like kind of like restarted again. And then they were hiring people at that time. So I was just nice at that point. Uh, was graduating and then also like looking for a full-time job, and they were actually looking for people too. So yeah, it was just nice. So I actually got in, and then I did not have an interview too. So yeah, just because I knew the people I worked with, and they were happy to hire me full time at that point. So my suggestion is actually if you can find an internship, that's super great while you are doing your BSc, because and that way you are actually getting industry experience. And then because so I cover CATIA V5 as one course in my engineering study, but that that is totally different what I did in Airbus, because different companies has even though it is the same software, the basic is same, but then the way that they design is actually different. They have their own standards, and then those CATIA V5 software is actually like customized to how Airbus wanted to be available. So it's pretty much getting the industry experience is good. Yeah. So yeah, if you can get an internship, so let's say your dream company is Airbus, but you did not get an internship at Airbus, but you got it somewhere, let's say Toyota or something like that. It's fine. I mean, the experience matters actually. They look at that. I mean, yeah. Hope that helps actually.
It did, thank you. And
Okay.
if it wasn't through a contact, say you were like going through a selection process, are you aware of the selection process?
Yeah, so some of my friends, like I said, like the career fair. So let's say you attend a career fair and then you submit your resume, and then so they will go through like they look at. So this is for internship I'm talking about though. I mean, yeah, for internship. So let's say you go to a career fair, even for a full-time job, it's about the same process, and so whoever the hiring manager or HR, they will look at your resumes, and then they will sort out resumes, and then so they will shortlist some of the candidates that they think like will fit to the company, and then they will give you a call, and then at that point they will probably ask you basic questions and say that okay, come for an interview, and then so one interview, sometimes you just have just one interview, sometimes you might have two interviews. Like let's say first interview is with engineer whoever, like say let's say design engineer who actually looking for someone to be like, I mean there's open spots in the company, and then they are the one actually directly like interviewing you, asking like because they are at that point they are trying to see if your skill set will fit the company needs, so you will have an interview, and after that maybe the HR, there will be like let's say if they agreed that you're good, and then they might call you again to have like more if let's say HR, maybe like human resources, they are the one actually doing the hiring, right? So they might be involved at the second round, saying that okay, this is the paperwork and final work, and then only then finally you get hired. So yeah, pretty much you would have an interview if you are going like the normal selection route. Did that answer your question though?
Yes, thank you very
Okay.
much.
Yeah. But if you have like a LinkedIn profile, like I know a friend who actually got hired through LinkedIn, like I think he was asking for an internship at Airbus, and then somehow he was somehow they did not have any internship. They only had like full-time positions, and so and then he forgot about it. Like he didn't, but somehow he actually added the person in LinkedIn, and once he graduated something they actually call like a year or two later, and then they asked like, if you're up, we have a opportunity if you want to join Airbus. So and then he got in, just like that. So I think, yeah, I think he had like a interview at internship for an internship, but somehow they did not have availability at that point. But somehow he went through internship, but somehow the hiring manager kind of like kept him in his mind. So later on, once he graduated, he actually got the job. So yeah, that's a yeah. So contacts, if you can build contacts, that's really great actually. Yeah. Because a lot of people will get hired through referral. One thing is because that was a time I actually refer one of my friend who was actually working with me in my mechanical engineering department. So I did not directly work with him, but I mean he was under the same process, and then my professor was actually like saying that he's good, he's doing a good job and stuff like that. So I was already doing the internship and he was graduating, and he asked me like, do you have an opportunities in Airbus? So I was like, yeah, there's this position. So like I think I told you, like okay, once I graduate, I actually went from a supplier company straight away directly to Airbus, right? So my supplier position became like that internship that I did, it pretty much became available. So I was actually referring my friend to that position. And he was saying he's from India, and then he said he actually have like CATIA knowledge back home, and he actually have he done an internship and everything, and I kind of believed him, and then so I recommended him. I know him, so ended up he have not actually worked on CATIA, so he was pretty much lying. And then I actually got a strike from my management saying that we only go through referral when you actually know and have worked with that person like thoroughly and know that his CATIA skills or everything like really good, So and somehow he wasn't performing really well, and then somehow even like when I try to explain, uh, he did not get it. I think he got so confused and everything, but that was a strike, and now I'm like, oh my God, cannot just recommend people. So yeah, that was a wake up call for me in a way. So yeah, even if you're referring, you had to make sure that you know that person really well. So that's that part too. So yep. Any other questions? Oh, sorry, I missed another. That's another question. Since I'm studying system engineering, will they hire system engineers to work in space-related organizations or space academics without being an aerospace engineer? Could you explain what system engineers does? Actually, I'm not really familiar with it. What do you? System engineers. System engineers are an intelligent professional who design, integrate, and manage complex large. Yeah, I think for sure. Yeah, they do have system. I just don't know that one. I think it's a pretty new major, I guess. But yeah, I'm pretty sure they do hire system engineering. So as long as you have like an engineering background, like basic maths and everything, you're pretty much good to go. I mean, like computer design, those skills, like it can be learned inside the company itself, because different companies actually have different software. So let's say Boeing uses 3D experience and we use CATIA V5, So it's about the same kind of software, like similar things that's happening, just that the interface a little bit different. So it does not matter as long as you have like a computer design background. I'm just talking about a design engineer perspective, and then like a basic degree qualification, I think you're good to go. So they do hire I mean, you don't have to be an aerospace engineer to be working in space related jobs for sure. Yeah, because if you think about space, everything. I mean, even geologists get hired for space related projects, because it's let's say Mars and Moon. I mean, they have all those soil that they want to analyze and those things too, and then even to put like rovers and everything, you pretty much have to know geology too. So yeah, I think everyone can go to space. I mean, as space related field. So yeah, I think system engineers will do just fine. Yeah. Any other questions?
The audience. So guys, since we are running out of time, you can drop down your questions to Ms. Malaysia by email.
Okay, so if you have more questions or anything, my husband a little bit shy to talk for some reason, and then he's really familiar with the Europe. So his PhD is in PhD in astrophysics, and he actually did his BSc in Sri Lanka as a physics. He did physical science, right? Yeah, natural science, at Open University of Sri Lanka, and then he came to Italy to do his master's in astrophysics, and then all that he actually applied through in Sri Lanka, and then also. After that, he actually, while he was doing his master's, he actually found a job he found a PhD that paid him 100% to do his PhD in Poland on astronomy. So that's what he's doing. Like over here, most of the US universities, they don't cover 100% for some reason. I don't know. Some do cover 100%, but some of the professors only cover half of the tuition. That's what happened to me actually, even though my professor was saying it's 100%, he only covered half of it. But most of the Europe PhD programs, they actually fund fully. It's not just PhD, even like masters, they fund fully. Uh, yeah. Even if you want to know like Europe universities and stuff, feel free to message me. I'll find more information about those and then give you guys if you're interested. Um, I'll send you my contact information one more time, and then also LinkedIn if you wanna add me, or ask question on that too is fine. Mm. Yeah, let me give you my LinkedIn as well. Mm. Yeah, over to you, Rashida, if there's no questions.
So thank you so much for sharing your experience, knowledge, and valuable insights. So, and even answering our questions in detail. So I'm sure everyone is walking away with fresh perspectives and renewed motivation. So, Shana, I think speaker, so we're actually glad to present the token of appreciation. So, as a sincere expression of our gratitude for our time, effort, and inspiring interest you share with us today.
Sure, thank you. Thank you for having me. It's an honor to talk to you guys too. And then if I can help you in any other way, and then if you learn something, that's a really I'm happy for it. So thank you so much for having me. See you guys. Bye.
Now we do have a small water tank session. So for that, I would like to invite Ms. Sarah Zaro to Secretary of the job.
Sorry, Tasha, I'm having trouble actually understanding you. Could you speak a little bit louder? Sorry.
Yeah, so we do have a small water tank session. So
Okay,
yeah, over to you, Sarah.
sure.
Am I audible, Rashida?
Yes.
Yes. Yeah, by the way, to be honest, what we witnessed today was more than just a webinar, I guess. I think it was truly a bridging between student rocket projects and real world aerospace. And as we come to the end of today's session, I would like to take a moment to express our heartfelt gratitude. First and foremost, our sincere thanks goes to our esteemed guest speaker, Ms. Marisha Fonseca, for taking the time to share such valuable knowledge and real world insights with us. Your journey as a design engineer at Airbus Engineering and the insights you shared with us today, literally we were able to explore so many new aspects of aerospace engineering. And I believe it's fair to say that at some point in our childhood, many of us dreamt of becoming an astronaut or at least being part of something connected to astronomy. So,
Yeah.
this session truly brought those dreams closer to reality. It opened our eyes to what the journey actually looks like, while also reigniting that sense of curiosity and excitement within us. And your insights were not only informative, madam, but also deeply inspiring, making this an incredibly engaging and thought provoking session for all of us. We are incredibly grateful for the willingness to engage with our SEDS community, madam. And once again, thank you so much, madam. And I would also like to extend my heartfelt appreciations to all the participants who joined us today. And of course, a special thank you goes to our dedicated organizing team of SETS Japura Rocketry Division. Your hard work, coordination, and commitment behind the scenes made this webinar possible and successful. And at SETS Japura, we'll be continuing to provide you more sessions like this. So to be in touch with us, please don't forget to join our WhatsApp groups and our social media platforms. You can join us by scanning these QR codes. And yes, thank you once again, thank you all for joining this session. Have a wonderful rest of the day. Good night.
You too. Thank you. Thank you for having me, Sarah.
Thank you, Sarah. And to our dear audience, guys, please make sure to fill out the feedback form so that you can get your e-certificate. So we hope today's session has sparked new ideas, broadened your perspective, and encouraged you to explore the world of engineering design even further. So stay connected with us, Tech Japura, for more exciting sessions and opportunities ahead. So until next time, thank you. Stay inside and have a wonderful evening. Keep learning, keep building, and keep reaching for the stars. Thank you.